Hello everyone, welcome back to MAC1105. In this video I will be discussing the last function in college algebra, and this is related to the function you just learned last week, the exponential function. So in order to start this function, let me go ahead and do a quick recall on exponential function, and based on exponential function we're gonna go ahead and get the log function. Okay, so this is what we know last time. So we know the exponential function goes like this. Okay, so this goes like this. There you go. It's an increasing one. For this one, sometimes it goes like this. Okay, so this is an exponential function when the b value is a growing factor. Okay, now in order to get the last function in college algebra, I'm going to go ahead and draw a straight line right over here that goes through the origin at 90 degrees. Okay, go through the origin and it cut at 90 degrees, so it cut it into half, make it 45 degrees. Okay, then I'm gonna make a reflection of this one. So we know that this one is f of x ab to the x. Okay, now I'm gonna go ahead and make a reflection, and when I make the reflection, it's gonna turn out to be like this. Okay, well, it's not really. I try to be perfect, so okay, so it's gonna be like that. Okay, so this function over here, the yellow one right here, is the log function, and this function is g. I'm gonna call it g of x is log b of x. Now you see that over here these two functions is reflected about the line y equal x. So this is the line y equal x. Okay, and if it is reflected about the line y equal x, according to the concept we already learned last time about one-to-one function, these two functions over here, the exponential function and the log function, they are inverse of each other. Okay, now we're gonna go ahead and in this video we're gonna talk about the log function. I will give you example, and I will give you I'll give you example when we talk about the domain and the range of the log function. Okay, so let's get started. So that is how you see the relation between exponential and log function. Now we're gonna go through the main part today. So log function. Okay, all right, function. All right, now first of all, let's talk about the standard form of log function. When the full standard form, when we have all the transformation in that function. So all the log function will be as follow: f of x equal to a log b of x minus h plus k. So we already learned this h and k is the horizontal and vertical shifting. Then we already know what a mean, the compression or depression, compression along the y, and this the number over here, the compression along the x, something like that. So that is the transformation. Now if I go ahead and let h and k equal 0, if I let h and k equal 0, then I will have log function of f of x equal log base b of x only when I let a equal 1. Okay, then I will have this log f of x equal log base b of x, and b is called the base of the log base. Okay, and x is called the argument. and the base of the log cannot be negative, so it must be greater than 0. Okay, the base must be greater than 0. It cannot be negative. It could be fraction, it could be decimal, but it cannot be negative. It cannot be equal 1. Equal 1 is okay, but it cannot be equal 0. Okay, and the argument, it could be any function over here. It doesn't have to be x. All right, now let me give you the first example. What if I have something like this, f of x equal log base 2 of x? So this is a very typical simple log function. So in order to graph this one, let's say that you have a calculator and you just need to set up the table, and we just go ahead and plug in some point, and we have the graph. And if you then you will see that it's gonna be turned out something like this, and the vertical axis will be the vertical asymptote. Okay, so let's try to do that. So at this moment you don't know the property of the log. Okay, so you cannot do the mental math right now. At this moment you have to use the calculator. So I'm gonna go ahead and plug in x equal 1 and x equal 2. Okay, then x equal 4. You have to plug in any number, but if you know the property, which is in the next lecture, then it will be easier for you to know what value you should plug in. So I'm going to plug in x equal 1, then we have log base 2 of 1. If you plug into calculator, it gives you 0, and log base 2 of 2, which is give you 1, and log base 2 of 4, which is give you 2. So with this information, I can go ahead and graph this easily. Okay, so we're gonna have here sorry guys, I have recently I have very bad allergy. So when x equal 1, so give you 0, so this is 1 over here, give you 0. Log, and when x equal 2, then give you 1, so you're gonna have right over here. Okay, 2, give you 1, and log equal 4, 2, 3, 4, that give you 2. There you go. Okay, and when x equal, let's say when x equal half, then let's see what happened. Let's do another one. When x equal half, I have log base 2 of a half, give you negative. If you to put into the calculator, give you -1. So right over here, right here. So you see that the log function will go kind of like this. There you go. All right, and the x-axis over here is the vertical asymptote. Okay, now think about it. We go ahead and apply the transformation horizontally, right? So you see that the vertical asymptote will be also changed. It's not going to be the same anymore. We already talked about transformation concept during the first module of our course. So if think about it, if the vertical asymptote move it to the right one, to the left 1 unit, then everything will be moved. See, everything will be moved. So but if you move up and if you move up and down, the horizontal asymptote is still there. So think about, let's think for this one right over here. If you move up, the vertical asymptote is still there. Okay. So the vertical asymptote is just move if you apply the horizontal transformation. Okay, so that is a very basic standard log function. Okay, as in sometimes the base is not 2, sometimes the base is 10, and if the base is 10, you can throw away the base. So basically, if the base is 10, you can write log base 10 of x as log of x only. So without the base, if you don't see the base, it means the base 10. Okay, and if the base, what if the base is the e value in your calculator, then you can write this as lnx, which is this one we call the natural log. Okay, and the way you graph the natural log or log base 10 is also the same as this. Okay, of course in many cases the function log could get more complicated. Let's say I have this function. I'm going to go ahead and put a bunch of transformation over there. Let's say I have negative 1 with a log base 3 of 3x plus 2, then minus 1. You see, for this one over here, we have a bunch of different transformation over here. If you want to know transformation, you can go back and review the transformation. But you see over here, we're going to have a horizontal shifting, we have a horizontal compression, we have reflection, we have vertical compression right over here, we had a vertical shifting down over here. So you see that there's a bunch of different transformation over here. And if you want to find the domain and range, just think about that. All the log function is going to be of course the domain and range is based on the graph. But if you notice, you see that if you look at this one over here, so the range of this one is negative infinity to positive infinity. It never change. It never change. So the range is always negative infinity to positive infinity. So the range is a negative infinity to positive infinity as the fact. Okay, it never changes. So I'm going to put over here as a fact that the range of log function, okay, is always go from negative infinity to positive infinity. But for the range, for the domain, it depends on how you shift it left or right. So let's say in example number 3 here, because we know that over here we have horizontal shifting, so we can find the domain of this. Let's say I want to find domain of this one. Okay, find domain in interval notation. If you want to find domain of this one, then this is what you have to do. Okay, you just need to set the argument, which is 3x plus 2 greater than 0, because I already told you that, you see it over here, if it is, you see, look at the graph over here, it's always greater than 0. We don't have it over here. We don't have it over here. If it is standard, but base, it is no transformation. So if it has transformation, you just need to set the argument greater than 0 and you solve for x value, and you see you have your x value is negative 2/3, and so from here you can write the domain. Domain will be from negative 2/3 to positive infinity. See, very easy. Okay, good. So now from now on you can find the domain of any log function. Okay, I don't think that I'm gonna ask you any question on the test for finding domain over here, but just for you to know that in order to find domain of log function, all you have to do is set up greater than 0, not greater than equal. Okay, because we cannot take the log of 0, so it's greater than 0 only. And in order to graph this one, it's kind of complicated. You cannot set up the traditional method, the table. You can, but kind of hard. So we have to apply transformation over here. And again, usually if I ask you to graph log function, it should be a very simple one. It's not nothing like this. Okay. Let's see anything else about log. Okay. Okay. Yeah, so I think that's all for the log function. Of course, there's some application of log function regarding to this concept, but because it focuses too much on physics, so I don't want to mention too much over here. Let me give you the application. I will do application or regarding to exponential only, not a log. Okay, so basically that's all for log function. If you have any question, please let me know, and I'll be seeing you next time in the next video. Bye bye.